Hey everyone, here is your next section of notes for Unit 1. So this page of notes is on measurement in the metric system, and you have a Word or a Google Doc to make a copy of and fill in as we go. So the first is just a question of the day. Why, in society, do you think it's important to have a universal system of measuring? Take one example and discuss it in your journal. So you don't really have a journal, you just have that notes page. So you can think of an example why universal system of measuring might be important. So this slide, the example is any carpenters. It's important for them to have a system of measuring so that when they're purchasing stuff, when they're building together, when they're sharing measurements, everyone's on the same page. And the construction of walls and roofs and houses or whatever will be done properly. So think of another example of why that's important and write it down in your notes. Okay, here we go. So measurement, in Chem 1 you learned that we use the International System of Units, which is also the SI system. That came about in around 1960. It's basically a revision of the metric system. It's used in pretty much every other country besides the US, but even in those countries it's still mainly used for scientific work, so scientists can share across countries. Okay. In the SI system, we have a base unit, which is a derived unit for each type of measurement. So our base units are usually grams or kilograms, liters, meters, things like that. So you should be filling in the notes as we go. So number 1 was the International System of Units, or SI system, was established in 1960. It's a revision and extension of the metric system. A base unit is something that can be measured directly, but a derived unit must be derived or calculated. So a derived usually has a prefix like milli, centi, kilo, anything like that. Okay, and then it says, what is the SI unit that's used to measure mass? So you just look at this chart, which one is talking about mass? It would be the kilogram. Number 4 says, what is the SI unit used to measure volume? So look for where it says volume on the top box, on the top section, and it's a cubic meter. It could also be a cubic centimeter. Okay? So now let's look at some of our derived units or our prefixes. So here's this chart. It has everything from your base units, deci, centi, milli, micro, nano, and then it goes up to deca, hecto, kilo, mega, and so on. Okay, so number 5 says, what is the metric prefix that's used to symbolize 100 of something? So you would just look at this chart, find where it says 100, and that's under hecto. So the prefix would be hecto for number 5. Number 6, what is the metric prefix that's used to symbolize 1/1000th of something? So we're looking at the chart, 1000 is under kilo. So, 1/1000th. So milli would be your answer to number 6. Okay. SI in the metric system is a decimal system. In other words, it's a system based on multiples and subdivisions of 10. So everything is multiplied or divided by 10, whether you're moving your decimal to the right or to the left. It's super easy to use once you become familiar with it. Converting SI or metric system to English system is a little bit more difficult because you can't just move the decimal. So that was number 7. You should have had English system. Okay, number 8 says converting inches into meters requires some calculations, right? Inches is the American English system, meters is SI, so we can't just move the decimal. So we're gonna look at this chart for meter. It says 1 meter is 39.37 inches. Number 9, 1 kilometer is 1,000 meters. That makes conversions easy because that's all the SI unit. However, if we're converting to miles, it's a little bit harder. So on my chart, what does it say for miles? It says 1 kilometer is 0.62 miles. Okay. Length and mass. The basic unit of length in the SI system is the meter. It's a little bit longer than a yard. The SI unit of mass is the kilogram, but you will be using grams much more frequently because it's a little bit more accurate since it's a smaller measurement. So all of our scales measure in grams. That was your answer for number 10. Volume is derived from length, and you can find it by just multiplying length times length times length. Or if it's a weird shape or a rectangle, length times width times height. That is meters cubed. So number 11, that's used to measure solid objects. For number 12, when we start talking about liquids and how to measure volume in that way, it says 1 milliliter is equal to 1 cubic centimeter. So basically, if you hollow out a cube, fill it with water, it's still going to equal 1 millimeter if it had a volume of 1 centimeter cubed. Oh, excuse me. Okay, so we should be on number 13 now. Density of an object is a derived quantity. It's just mass divided by volume. So density is just a ratio. It's the mass of an object divided by volume. Density does not change for a particular substance. That's number 14. Since density is a ratio, if we have a chocolate bar and we find the density of it, and then we break that chocolate bar in half, the density is still the same even though the chocolate bar got broken because it's just a ratio. Okay, so you might have a metric ladder on your notes. It wasn't showing up super well earlier. Let's see if I have it on my slides. Nope, I think that's it. So this is kind of where we stopped on our slides. Let me see if I can find that ladder really fast. Here we go. Oh, it's not showing up on here either. So it doesn't really show up on the iPad, so that's okay. We can talk about it later on. Basically, just know that when you are going from different things in the metric system, you really are only moving the decimal. So you can move it left or right depending on how far the unit is from each other. Again, when we get to that more in detail, I can go over it again, but the little picture that I needed is not showing up right now, so we'll talk about that later. Okay guys, if y'all have any questions, let me know. On the notes page, that's where we stopped in class. If you want to do those conversions that are at the end, numbers 1 through 12, and then again 1 through 8, feel free to do that. We did not do it in class.